So now it is 5 o'clock, top of the hour. Good afternoon, everyone. Thank you so much for being here. Before I introduce to you Ed Tahoun. It's Tahoun, right?
Oh, yes.
So we want to give a shout out to our sponsors for the Packet Hacking Village sponsors this year. Platinum sponsors Aries Security, Gold, Deloitte Canada, Vigilant, Bronze, T-Mobile, Copper, BPM, 909 Cyber, and 4542. Thank you so much for their support and helping us get our village up and running this year. It is now my honor to introduce to you our speaker for the Packet Hacking Village Creator Stage Talks. And our final one is actually someone that we know, Ed Tahoun. Ez.
Thank you. 100%. I appreciate it.
Yeah.
Grateful.
There you go.
Ooh, there we go. Hello, everybody. I hope you had a fantastic second day at DEF CON. How is everybody feeling so far? Yeah, woohoo! We're all pumped. Are we all asleep? We're all tired? Any blue teamers here? Blue teamers? What's your name? Manolo. Any other blue teamers? Randre? Alan? Other blue teamers? Not much blue teaming? Of course, the one, the only Michael. Okay. So, in blue team, what are some of the problems that we have? False positives. Okay. So what do we do about the false positives? How do we solve this problem? How could we solve it? We have all the experts. We solve the false positives with what? AI, machine learning, all the cool stuff. But what do you want them to do? You want them to do better detections? Or do you want them to do better correlation? What do we want to do to solve the problem of false positives? All I need is some job security and some good food, yeah, and some good love, and that's it, and some good party. But I wonder, what are some things that we can solve? Is it the correlation problem? Yeah, that's a big one. What's the problem with correlation? It's hard. What makes correlation hard? When two events are occurring in sequence, I would like to correlate them because that would be an indicator of a bad actor or some sort of an actual attack. Versus when everything is siloed or isolated, I don't really know if it's a false positive or not, and it's a big problem with false positives, right? Okay, so what is so hard about putting two events together? Anybody here writes correlation rules? I know we use correlation rules. Anybody here writes them? You try to write correlation rules. What's the hardest part about writing correlation rules? Yeah, a lot of false positives. What's an example correlation rule? Put this event with this event if they both happen within 5 minutes on the same machine?
Yeah, for example, like if you write a correlation that you get like 10 connections, outbound connections to via, let's say, SQL port.
If you get 10 outbound connections to an SQL port, why do I have 10? I want them to be correlated.
Yeah, but it turns out that all Tor connections.
Yeah.
All the software that bypasses firewall, they use that as well. So.
They also generate a lot of connections, which ends up with a lot of detections and a lot of net flows, a lot of firewall logs, all saying the same thing. So I just want to correlate them. That's a fantastic point. So with that in mind, I can essentially try to correlate things that have come from the same session. For instance, if I go and I surf a website for a bit, I'm generating a bunch of the same essentially data points across multiple data types. So for instance, if I go to a website and I go for this website for maybe 2 minutes, what am I generating? I'm generating a bunch of stuff. Like what? I can generate 50 net flows, right? Like the 10 SQL connections, I can generate 50 net flows all saying the same thing. I can generate 50 traffic logs from the firewall, all saying the same thing. I can generate 400 sysmons, 1,000 EDR telemetry, another 1,000 Windows event logs, all saying the same thing. And then ideally, in correlation, I put them together, right? This might not mean it's an attack, because what you were thinking about is put the attack story together. But what he was thinking about is put the relevant things together. So correlation means two different things. First, put relevant things together. And then second, put the attack story together. So this is one session that generated so many traces that are all describing the same activity. So if I, for instance, group the net flows and the Fortinet and the sysmon and the Windows events that all came from me going to this website for 2 minutes, this is one level of correlation, of grouping relevant things. Yeah? And then the second level of correlation is gonna look something probably closer to, I got de-auth of my own network, so I gotta turn on a hotspot. But essentially if I go here and I go maybe to something like this, like the Singapore Health attack, what I'm seeing here is an attack storyboard, like the one you were talking about. So that is the kind of correlation that you were talking about. Put the attack story together, right? So first I gotta put the relevant things together, and then after that, I keep on getting de-authed, by the way. Probably someone is de-authing me from the other networks. I'm just de-authing everybody. So I'm gonna put another hotspot. But yeah, there we go, we're back again. But essentially, we have two levels of correlation. One level puts attack stories, and one level puts similar things. So an attack story would look something like this, where you have things from tactic 1 through tactic 11 or 10 saying the attack story. What's the attack story? Machine 0, I had, what on machine 0? I had initial access. I saw a trace that looked like initial access, like drive-by technique or some sort of a USB infection or something. And then I see something on execution. If I put this story together, that is the correlation that you're looking for, right? But if I do the initial part, which if you remember was first put the relevant things, all of the things that come from the same data source are a bunch of consolidated data source, like net flows, firewall logs, Windows events. I'm consolidating and correlating things that are similar. That allows me to be also doing a level 1 of correlation. So correlation means two things. So again, going back to correlation, why does nobody here write correlation rules per se? It's hard in what? Now that we know what is correlation, we know the objective. Objective is group similar things. After you're done with that, please group things that make causal stories. Right? Isn't this what we have just agreed on? Essentially this. We have just agreed that this is what we want. We agreed that first, group similar things. After you're done grouping similar things, what do? Make attack stories. Right? So this is the objective. How do we get there? We write rules. Okay, let's write rules. What's wrong with rules? Why don't we write more rules? Even added bonus is after you group things that are related, you will notice there are so many duplicates. The data is full of duplicates. And I can show you here my Notepad++. In this case, if I pull you these Fortinet, do you notice something in the Fortinet firewall logs? The same IP a million times. Do you notice something from the same session? Instead of firewall logs, I take a look at, let me take a look at NetFlow logs. So in NetFlow, do you notice something? Same IP. 500 things. 500 of these events describing the same IP. the same port, the same IP. How about Windows event logs? How about firewall traffic logs? How about any kind of logs? They're all sharing the exact same information in a very duplicated fashion. And you can even see that in, I'll give you a story. I wanted to reduce some data, speaking of the deduplication. I wanted to reduce some data for one of my people that I was helping. And in this kind of engagement, they were thinking, we want to reduce the amount of data that, for instance, goes into this SIM. And I was like, okay, how do we reduce this data? And they were like, the first thought is, let's remove the events that we don't use, that we don't correlate. And I was like, okay, and let's reduce some events. But then when I was trying to reduce the events and filter the events I don't want in my SIM, and filter the fields, like, you know, the packets, the bytes, the number of bytes transferred in this net flow, yada, yada, yada. I was looking for fields that I can remove, to remove amounts of data that we don't need to put in the SIM. I took a look at the filtering, but then I look at the other side. What do you guys see? Anything stands out in the data? Huh? It's all the same. So I can reduce some events. I can say, you know what, Windows event log, event number 3, I don't want that. Nah, that's a very noisy event. Maybe I can reduce like 5% of my data. But what's the point if my data looks like this? You want to reduce 99% of your data. You don't remove events. What do? You deduplicate. So going back to our plan, devised by, sorry, what was your name? Manolo and Bill and Manolo devised our plan. We know exactly what we want. We want to group relevant things. And at that point, I kind of suggest we also dedupe. If you group, you dedupe. And what are the groupings? The groupings are based on similarity, similar session, as Manolo said, and attack activity, or attack story, or attack chain, as Bill said. So we know what do we need. Again, we loop back. What's the problem with correlation searches? Why don't I go, let's say, to ChatGPT and make 1 million correlation searches? Or let's say me and you in this room, we sit down and we write 1 million correlation searches. Especially if they're already enriched with techniques and we already have tactics for everything, like this. If every single event has techniques with some sort of enrichment machine learning or some sort of enrichment rules or whatever, the moment we have techniques and I can build stories from the tactics, I can also write some cool rules. So why don't I do this with rules? Any thoughts? So we know the data is full of duplicates because, you know, some people get paid about log volume. They don't get paid about log value. So they want you to have a lot of log volume. So we end up with a lot of duplicates, a lot of redundant data. The data all looks the same, but it's terabytes and terabytes, right? Yeah. Meaning that I can come to your organization and bankrupt your organization by coming to your guest network every day and watching some Netflix. I will generate you 500 extra terabytes by the end of the year, so that your SIM costs double what it costs today, and you have to let go of many people and you have to reorganize your SOC. But I will not do that. But now that we understand that the data is very fragmented, very scattered, very isolated, and very duplicated and very redundant, we know the solution, right? Null already said group the similar things, dedupe them, put stories. What's wrong with that? Why don't we do that with rules? I have a GitHub with machine learning stuff that will do that for you out of the box. But I just want to understand, what is the hard part? You think this technology is hard to do with correlation rules? You can group and dedupe. Matter of fact, you can do this with not very advanced machine learning. You can use it with basic machine learning. When I was a little kid, when I was 7 years old, there was MySpace. And my MySpace account, it would tell me, this person is relevant to this person, you might have known them. These people, you know, you might know them. They're relevant to each other. They're similar to each other. It's a recommender system. YouTube tells you this video is relevant to this video since 2010, I think, or something, right? So the technology for finding relevant things and doing what Manolo wanted to do Find things that are relevant. Has been there very long time ago. Right? What is so hard? Where's the catch? Bill, any thoughts? Any thoughts? What would be so hard in the grouping? Why don't we have this grouping already? Manolo? You write correlation rules. Why didn't you already correlate all of the things? How many correlation rules do we need to put the things together? A lot, 1,000? How many correlation rules do you have today? Out of the box, in whatever sim you use. Huh? Less than 1,000? So we need like a slightly more correlations? Is that the point? We just need more correlation rules?
For example, let's say at PDX, so you have like hundreds of UDP sessions to read, but on different boards. So that could like if it were like a database, but
Okay.
your PDX, that's how it works. That's how it's supposed to work. So
Oh.
you have to look at, and that's like a really like easy example that everybody can understand. But then if you like incorporate like business context into it,
I love it.
then that's a hell of a lot harder.
So Manolo says, you can group things, but not with generic correlation rules. Because generic correlation rules do not understand the context. There are so many things that you need to consider when you're doing the groupings. They could, for instance, not have the same port, but have the same protocol. They could, for instance, not have the same IP, but the same user. They could, for instance, not have the temporal proximity of 5 minutes. They're not 5 minutes apart. They are 5 hours, 5 days apart, but they're still to be grouped together. So groupings are not something that you can write some basic rules that look at certain fields and get. To do proper grouping, you need to look at everything and understand in these certain scenarios, how do we group them, right? In that case, you really need to look at all of the fields. And if we're looking at all of the fields for correlation, cannot do it with rules, because rules are very, very narrow. Rules are when you're looking for something specific, for a pattern that's very, very, very specific. You write a rule. But if you want something generic that looks at everything, you get maybe some sort of a probabilistic model. And we go back to the same recommender system that we talked about, the YouTube videos, for instance. You think someone wrote a video suggestion logic that says, if this YouTube video and this YouTube video share the same channel and the same hashtag and the same number of comments, then you recommend them as relevant to each other? No way, right? They just looked at everything. They looked at the video duration, the video transcript, the video topics. They looked at everything. So you need to consider everything, because context is key, context is king. And if you do the right context engineering, you're looking at all of the fields to understand what is actually relevant to what. And in that case, you take your data and you essentially put it on something like this. You get every single field and you put all of the fields for consideration. How does machine learning do it? Any data scientists in the room? Not much data scientists, but very simply, once you have all of the data, in data science we have a very fancy way of saying this is close to this because they are closer to each other in the dimension space. Let's say it's 3D dimension, we give it X, Y, Z coordinates for all of them. So these two things are closer to each other than the mic. So these two are to be in a group. This one is not very close to them, so it's not going to be in a group. So it's a matter of just representing the data in a dimension space and then finding things that are similar to each other. But notice, we have looked at all of the fields, not with rules where we have to select fields and write very, very specific patterns. We can't do that to solve the problem that Manolo was talking about. We need all of the fields to look at all of the context. Yeah? And at that point, we find groupings that can be very different time span apart, can be very different IPs, can be very different whatever. None of the groupings will be exactly the same coming from the same rule set. They will be depending on the use case of what was closer at the time. So you would put all of the events that you have in something that looks like this, and you would look which of them happen to be closer to each other than to something else. Instead of writing a rule that says, if this has the same IP as this, and they both happened within 5 minutes, then we put them together. As we started in this session, we were talking about these rules. But now we're thinking, everything has to be grouped. Just figure out which is the closest. Closest on what? Closest on everything. Look at all of the fields, yeah? And that is how we do our grouping before we do the deduping and before we do the correlation. So now that we know how do we do the grouping, thank you, Manello. We know how to do the grouping, thank you very much. You have instructed us on how to do our grouping. How? Again, the recap is, how do we do that? Very simply, we find things that are highly related to each other. How do we do that? Manello says, find events that are related to each other across everything, across context. Do not really write rules for certain things because context matters. Okie dokie, we'll do that. But then we need to build the story. So Bill comes in this case, and tells us how do we find things that are part of the same attack story. What do you think? So there is some sort of sequence. In this case, we're not looking at things that are close to each other. We're not looking at things that are related to each other. No. These things are sequential to each other. They're causal to each other. I need to form a story. Do I have any kind of framework for stories in cybersecurity? What is a framework for a story? A kill chain. So we need this idea of what forms a sequence. It essentially looks something like a kill chain. What is a kill chain? Do you guys remember the attack we were looking at in the beginning? Something like this. An attack like this. This is Singapore Health, by the way. There's a story. There is a storyline. There is a storyboard. Going left to right. What is happening left to right? Any thoughts? Left to right. What is happening? Top to bottom, it's time. So August 2017, September 2017, October 2017. This is time. But what is happening left to right? It's the depth of the attack. It's the attack life cycle. It's the attack progression. It's the story. I'm seeing the story of the attack. The story started with, oh, I have an EDR alert here, and then I have an NDR, a network alert. I had some endpoint traces here, and then I had a network trace here. And then later on, I had some whatever, and I had some threat intelligence in the beginning. I'm putting together the story. So I'm done with the grouping, and I go back to my notes, and I'm like, okay, I finished the grouping. I already have things that are relevant to each other. Not only that, I'm also deduping them. So the data is so much smaller because I removed all the duplicates and I grouped all the relevant things thanks to Manello. But then I asked Bill, how do I put it together? And Bill tells me, you know what? Put together the story. The story you put together in a way that tells you the attack progression, the attack life cycle. And in that case, when I look at the attack life cycle, I know that the attack might be missing some detection gaps, right? I don't always see all of the tactics. I might not have a way to see privilege escalation. I might not have a way to see defense evasion traces. But I know that I can put together the story if it looks something along the lines of a couple tactics that come in sequence. And the key word is sequence. They're sequential to each other, right? I have a session that I went to a website, and I have another session that tells me there is some weird execution happening on my machine that I went to the website of. And I have another session or group of similar things that tell me there is some sort of exfiltration. And then I'm like, aha. I went to a website, and then later there was execution, and then later there was exfiltration. That seems like a kill chain. And light bulb comes up, I'm like, okay, I see it. And in that case, I use a model, again, for putting things that are sequential to each other. If you see a bunch of things in the beginning, look for things that can complete their story. And ideally, they are kind of within some sort of temporal proximity, within the same timeline, ideally. But again, similar to what we did in clustering, if you remember in the grouping, I cannot write rules. Why don't I write rules? Because I don't know always exactly what's going to happen, but I know that if I have my events, I'm not going to write exact rules of how the chain is going to happen. I don't know. Maybe it's tactic 1 and then tactic 5, maybe tactic 10 later on. Or maybe it's just tactic 2 and tactic 4. I don't know how the story will look. I cannot write rules. What I'm going to do is I'm going to say if they're close, you group them, and if these groups are close to each other, now that I group them, if these groups are close to each other, and these groups have tactics that are sequential to each other, they're part of the same story, right? So if the green circle is tactic 3, and the orange circle is tactic 2, which is execution, I know that execution being close to privilege escalation or persistence, for tactic 3 is persistence. If execution and persistence are close to each other, they happen to be sequential, then Bill comes in and he's like, you know what? That's a story. That's a story right there. These two, put them together right now, that's a story. And how does the story look like? Does it look like the PDF that we started with in the beginning from Singapore? Yes, of course. Why do I need to build stories after the breach? I'll build it before the breach. That's fine. So before anything, I'll build that story. And that story is going to be similar to the detections. You know, you have some false positives because the detections are not that good. But the stories will come together and form probabilistic things that you need to look at. And how does the story look like? Does it look like the first Singapore Health? Exactly. I have entities with different colors. And I have, what do I have on this side? I have timeline, top to bottom, time goes through. And what do I have left to right? Anybody? Left to right. What do I see? The story. I see the kill chain progression. I see the life cycle progression, as you mentioned, right? So that means that I turn all of my logs from single, isolated, disparate, scattered and fragmented logs to groups, thanks to Monello, to stories, thanks to Bill, with very basic stuff. And why don't I have rules? Because rules, as mentioned by Monello and Bill, are very, 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 very narrow. And the problem is, you can come up with so many possibilities where the rules don't apply. But if you look at everything, you find things that are closest to each other. You don't know exactly the relationship, but you know that they're closest. They're the closer ones than the other ones. They happen to be closer to each other. And hence, we group them, we chain them, we have stories from everything in our traces, because everything in our traces is not isolated. So everything must be grouped. Not everything will make attack stories, by the way, but everything will make groups, by definition. Because there is not a single human activity that generates one event. You go to a website, you generate 1,000 events on the network, and 1,000 events on the endpoint, and 1,000 events on the web proxy, and 1,000 events on whatever. You know for sure you have to group everything. And correlation rules, they never group everything. They group very specific patterns. So now we know what's broken with correlation. We know what we need. We need to split correlation into two different things. We consolidate and essentially we group similar ones, right? So we group, we call it grouping instead of correlation because it's different. And we stop using the word correlation. We essentially, I should wake up now, but we group relevant things, right? And then We put together stories from these relevant things. But everything should be grouped, for sure. What is the added benefit of grouping everything beyond seeing the entire behavior represented in one group right away, instead of hunting things through the network and the web and the event logs and the telemetry? What's the added benefit? Anybody can think? Anybody remembers? What do I do when I group? It rhymes with group. Group and, I'll give you a hint. Group and dedupe. There you go. What's your name? Zain. And Zain immediately comes to the rescue. Dedupe. Because you grouped. What's the benefit of the deduping? Why do I dedupe? Because it's cost. Because money. This industry, people get paid for log volume, not log value. So they want you to have a lot more volume. You pay per terabyte, my friend. You pay per gigabyte. So your logs are doomed to look something like this, unless you do something about it. But we have Monello to our rescue, which is essentially coming in with the logic of group everything. And then Zain comes in, he's like, dedupe everything that we just grouped. And then the added benefit is, now that I have groupings, Bill wants to find actual attack chains. He doesn't want to be looking at, isolated things that might be false positives. I want to see the attack chains. So I group, dedupe, and my groupings can also show attack chains. And I end up with essentially where I started. Group, dedupe, and make attack chains. Why not with rules? Because I need generic things. Now the question is, how do we do it? We talked about the architecture. We talked about, in theory, how to do it. We have a perfect plan. I can plug it into ChatGPT and get the code. Or I can go ask my software engineers to go build it exactly. Even better, don't do that. Go to my GitHub and grab it from there. And with that, you will ask me, now that I have this code that groups and dedupes and makes attack stories or attack flows, where do I put this? Do I put it before the sim or do it after the sim? Well, the sim is kind of expensive, so if you're going to reduce the volume, do it before the sim. Anybody here uses Logstash or Cribble or Splunk Forwarder or any of these? Not really. Little bit. What do you use? Use Logstash? What's your name? Jason? So Jason uses Logstash, and Jason is like, I don't know how to put it before the sim. Well, the easy part is, it's a very small algorithm. So your Logstash would call it within Logstash. So within Logstash, you will call this algorithm, and you will take tons and tons of siloed data within Logstash and group it, and then dedupe it, and then correlate it into attack chains that are probabilistic, and then after Logstash, send it to wherever you want to send it. But what does that leave the rules for, you might think? So if correlation is done without rules, and grouping is done without rules, what are rules good for? For very specific things. When you open your Instagram or your TikTok or whatever, there is a feed of things that you are likely going to look at. But you can always search. Search is when you know what you're looking for. So what do the rules do for me? And that's why you can call them correlation rules, but these platforms, what do they call them? Correlation searches. They don't call them correlation rules, or correlation searches. Because these are searches. You're searching for something in particular. Anybody here uses searches to look for things after an APT report comes out? They tell you the IOCs, the IOAs, and you go and you search for them, right? You're searching. But in real time, don't search. Don't search in real time. You just open your Instagram, your TikTok, whatever you use, and immediately it has a feed of things that we know are grouped closer to the things that you like. That's it. So your data, big data, you never interact with it without some sort of grouping already. You always go into the internet, it groups things for you all the time. Even your Gmail groups your emails for you all the time. Primary, categories, whatever, forums, promotions, spam. You never interact with big data without automatic grouping. Other than in cybersecurity, well, not anymore. Now we go into cybersecurity, whatever thing you look at, whatever big data you collect, it's already grouped. And the added benefit is, instead of paying for 100 terabytes, because this industry is based on log volume, you're paying for 1 terabyte. So instead of letting go of half of your team next year because there is no budget, let's increase the budget. And let's lose no data. Next time you're in a SOC meeting and people are like, let's reduce the data by filtering out events and filtering out metadata. Be like, no. Let's just dedupe. And you would save a lot more. Because if you look at the promises of data filtration, they promise about 10%. From 100 terabytes, you might go to 90 terabytes if you lose half of your data. If you lose, some of your events. But then compliance is going to be like, oh, no. We need those. So you put them in an S3 bucket and you put the rest in the SIM, and it's a whole complex architecture. Keep it simple. Keep it simple, stupid. Right? So keep everything in one place as much as you want. Just dedupe it. That's it. Any questions about the amazing presentation put together by Bill, Monello, Zain, and Jason? You don't have any questions for them?
Criteria are you using? Basically spanning a second, 5 seconds, a minute.
Out of the box, or is there a limitation? There is no limitation. But out of the box, I think it's like 10 minutes or 5 minutes or something. I mean, the more. Oh, you're asking about like the use case. So most people, most of the logs, you don't care if they appear in your SIM within even an hour. So most of the SIMs that are next generation in the cloud, they're actually very slow. By the time something happens, I come to your network and I watch Netflix. I generate a gigabyte worth of logs on net flows and firewall logs and all of that good stuff. By the time you see it, there's a little bit of a delay, about like maybe up to an hour is fine. However, there are some critical things. The net flow might not be very critical, the guest network might not be very critical, but this extremely important CEO laptop, the EDR, or the endpoint detection and response, or the antivirus essentially, coming out of that endpoint, because it's a CEO, I want that right away without more than maybe 10 minutes. 10 minutes is my maximum because I gotta respond to it. I have an SLA, or maybe 2 minutes, or maybe 2 seconds, whatever it is, depending on my industry. So these, you can put them on their separate data path that is so much faster. But then most of your data, you can put it in these group and dedupe. And Bill's question is, if I'm grouping, am I grouping on 5 seconds of data, 5 minutes of data? I don't know. How much data do you put in your SIM? How much data are we talking about? Because time only means how much data am I putting in a bucket, and then I'm looking at this bucket and I'm removing the duplicates in the bucket. So do you have 100 terabytes a day? In that case, it doesn't matter. Make it 2 seconds. You're gonna dedupe the 99%. But if you have 1 terabyte a day, 2 seconds, you will dedupe about maybe 80% instead of 99%. Big deal. We're saving 40 million instead of saving $50 million to Splunk over the next so many years. But, or whatever, Elastic, Azure Sentinel, whatever it is, they all get paid based on log volume. Compute even, like your compute based on log volume. Everything is based on log volume. So how much would you like to win is a matter of essentially your configuration. But today, we're not doing anything. So anything is better than nothing. Let's save 40% rather than 99%. Let's have the worst configurations. We're still saving 40%. And to put this in dollar amounts, because Bill seems to think about the dollar amount aspect for this, let's look at it. So in this case, we went from about 1,000 kilobytes or more than 1,000 kilobytes. We went to 75 kilobytes. That's 93% volume reduction. Let's put it in a dollar amount without 93. Let's assume 70%. I think I have a table down there on 70%. And the table here shows you some pricing. Let's assume you have Splunk. If you have Splunk, and let's assume some people were saying like 50 terabytes or 10 terabytes or whatever. Let's assume you only have 4 terabytes a day. You're a very small organization. 4 terabytes a day. 4 terabytes a day. How much are you paying today? The lowest is like 3.8. The highest is about 4.8. Something in these ranges for the license and the cost. Okay. If I reduce it to 0.25, I'm not going to reduce it 99%. No. I just reduce it to 0.25. About 85% or 90%. Not really 93% or 99%. No. Just moderately. And I put 0.25 instead of 4. The new price, instead of 4 million, I'm going to pay 0.3 million. And that's like because, I didn't configure it very nicely. I only got, 80% or 90%. I could have gotten 99%, like as said in DEF CON. But I didn't configure it very well because I didn't talk to Ez. I just used the GitHub without talking to him. So didn't get the best configurations for my environment. That's fine. You present your team with $2 million in savings. But your team doesn't care. Your team they don't want to get fired because the budget is low. So your boss would really care about getting the 2 million. But your team would care about what? Your team are essentially the people in this room. What did the people in this room care about? They cared about false positives. They said, we came here because security is broken. And I said, people, why is security broken? And people are like, false positives. Well, if you have false positives and you have them grouped, you don't have 1 million false positives anymore. You have one group of false positives. You don't have 1 million spam emails. You have one group with 1 million spam emails. And hence, it's not noisy. It's not overwhelming. It's one group, right? Because you grouped everything that's relevant to each other. And you don't call them false positives, you just call them sessions. Why? Because you have differentiated between benign activity that is just grouped because they're similar to each other versus causal attack stories. This is the good stuff. A false positive would not somehow align with some other false positive, somehow on the same entities, somehow that just happens to be of sequential tactic around the same time. False positives don't do that. And if they do, your false positive rate goes from a staggering amount of false positives to essentially a minority of false positives. Because false positives don't stack together into a story. And if they do, it's like a negligible amount that people would not really complain about. So your team wouldn't be complaining about, oh my God, we hate false positives. And be like, it was surprising. I saw a false positive the other day that aligned with another false positive that made a story. That was a rare moment of seeing false positives in attack stories. But in siloed logs, in siloed events, and events that look something like this, and events that look something like this, my friend, all of them are false positives. The moment they turn from a false positive into an investigation is because you've already spent the entire weekend on it. They're all false positives by default. That's why people come into these rooms and they're like, oh my God, I hate false positives. And we can all bond about hate of false positives because all of our data is false positive. All of our data is noisy. All of our data is garbage. And that's why we can all laugh about garbage in, garbage out. I do the same thing because my boss wants it. I do the AI thing because the boss wants it. But it's all garbage in, garbage out. And we can all have beer and laugh about it at the pool party and be like, yeah, Security is broken, but I'm here just for job security, you know. But all of this is a scam. We don't have to say that anymore because we don't really be overwhelmed with false positives and we have to sit down and some of us might write correlation rules. We don't need that. From now on, we look at these. From now on, we don't really have the problem of, oh my God, false positives. We have the problem of, interestingly, there was a story that was interesting. Let me contact the escalation team, let me contact the IR team, let me figure out how to feed this to an AI that can tell me this story is interesting, that can tell me what's up with this story. Maybe I can go and I can investigate the story and add more things to the story that the generic attack story building algorithm did not see, but I saw, because I know my environment better than it does. I know my attacker better than it does because I'm a threat intelligence expert, okay? You add to it instead of starting from zero. Any questions? I know it's the end of the day, so I really thank you for not sleeping on me. But I've had a lot of energy drinks, so that's why I'm not sleeping just yet. But any questions? Yes.
What are the actual algorithms you were using?
What's your name? Andre. Andre, the actual algorithms, my friend, are, I start with enrichment. This is a natural language processing classification problem. I use something called a language model. Language models are kind of, in natural language processing, similar to ChatGPT, but much smaller. The smaller the model, you see it's missing an L. It's just LM. Usually big models, ChatGPT, yada yada, they call them LLM. Large language models. We use small language models. They don't speak English, they speak cybersecurity. So this is natural language processing for the enrichment. What does this do for me? Every log has techniques. Why do I need every log to have techniques, every event to have techniques, every alert to have techniques? Why? Because I want to group based on the similarity. So I'm enriching things before I group them, right? And grouping is based on what algorithm? What do you think? Clustering models, k-means, db-scan, whatever you want. Clustering. The same technology used in the 80s. No need for large language models that are new and fancy. Very expensive. How would I get you all of these savings if I'm running a humongous GPU data center to do it? It's very expensive. And how would you like it? It's not going to be explainable or auditable or transparent. You wouldn't know. 50-50. Sometimes it works. Sometimes it doesn't. It's large language model. We don't know how to figure out what's going on. But small model, clustering model, it's explainable. It's interpretable. You can go and you can fix it and you can teach it. You can audit what's wrong with it. It's not black box. It's white box, transparent. You go and you tell it, oh no, this story that you built, it's missing this piece. You need to learn how to add this piece. Okay. So the grouping is based on clustering. The grouping was presented to you by Monello. And then, if you remember, Bill presented something else, which was, what do you think? The chaining. So grouping, clustering, enrichment, natural language processing, chaining, sequencing models. If you remember, Bill used the word sequence, sequencing models. What's an example sequence model? So an example language model is BERT. An example clustering model, k-means or db-scan. An example sequencing model, something called Markovian models, since the 70s. What do? They find sequences. For cybersecurity, for anti-money laundering, for whatever it is. They just find sequences that are interesting. You define what's the sequence. In this case, we define the sequence as these tactics that come after each other. That's it. But all of the technology aside, we know what we want, and we can describe what we want, which is way more valuable than the technology. Because we all know people process technology. Technology is the last. Technology is the easiest. You need to understand the process. You remember the process. You will not remember the technology. Technology, maybe you will remember to add me on GitHub or LinkedIn or whatever. Maybe you will see it one day. But process is what you will walk away with. And you will implement the technology one way or another. The worst implementation will still get you fantastic savings. Will still get you fantastic false positive reduction. You don't need to use my implementation. Use some other technology. Build your own. The process is what was presented by Bill, Monello, Zane, and Jason. I'm the guy that builds the technology. You will find a million of me. Technology is easy. Any other questions? Does that answer your question? Any other questions? Did I miss some other part that was important during correlation? Did I oversimplify it? Did I miss a nuance? Did I miss something that was important? Is there something else that we needed to add?
How can you incorporate business?
I love it. How can I incorporate business context to it? How do I actually know what this entity means? How do I actually know that Monello has a laptop, an iPad, a phone, all that are used by him? How do I know? How do you know today in Splunk? You build lookup tables with enrichment. So Monello just says, dude, you talked about enrichment, but I don't think you did very good enrichment. Your enrichment was pretty simple. Your enrichment was simply MITRE ATT&CK TTPs. You have enriched the event. I don't see you enriching the entities. The event is interesting, but entities, you forgot them? How do you enrich entities? The good thing is, entities, enrichment, is not something that you need a classification model for. You just need a lookup table. A lookup table that says, this machine is used by this user is in this business unit has this manager, yada, yada, yada. In Splunk, I think it's called Asset and Identity Management, lookup tables. So you build a lookup table. Can your AI project find a lookup table and use it? It can predict or infer a lookup table, but it needs the human to actually go and validate it. I wouldn't take you to the UI right now not to bore you, but if you go here to app.sapienta.io and you log in and you essentially get any of them, I don't know, I can get you some very quick, maybe product tour or something. But essentially you can get enrichment tables. So I gotta go through a few hoops, but long story short, when you download the software has lookup tables, and it will fill in the table for you to tell you what entity is relevant to what other entity based on entity predictions or inferences. It will infer that this MAC address and this IP are related to this user because we have seen them grouped together so many times. Remember our groupings? So in these groupings, these are events, but inside them there are entities. If the entities group together so many times across your data and history, it will tell you, you know what, I think they are related to each other. I think these are related entities. And then they will put them in the table, and the table will tell you these entities always appear with each other. These entities must represent each other. And in this case, these entities, this one and this one, will have similar color. So the color will be very similar. Because the model thinks, because they have appeared together so many times, that they are related. And then you will go to the table, and you will see some inferred entries, and you can enter your own entries. For instance, where do you get the entries? You go to, do you have Active Directory? Active Directory tells you this user, this domain, this business unit, this whatever. You have a lot of information. You give it to the model, and it knows the business context. It knows that me and you, we work in the technology department, but Bill works in the management department. And hence, events between me and you are kind of closer to each other. Our entities are closer to each other because we share a characteristic. We all are in the same office, let's say in Las Vegas. we all are in the same department. While Bill is with us in Las Vegas, who is closer than Zain, who is not in Las Vegas, he's in LA, and hence he's closer to our entities, but not as close as me and you because he's in a different department. So from the entity tables, the distances in clustering will essentially be impacted by the entities inside these events. Because every little dot here is not a dot. It's an entire graph of all of the fields enriched with techniques and all of the entities enriched with relevant entities and relevant entity information from Active Directory and yada yada yada. Does that answer your question? Any other questions? I'm all yours. You're gonna assume this is like private performance, private consulting, whatever you want to call it. Ask me all the questions.
So, like, you mentioned the open source project, but there's also like a commercial product.
100%. We sell the license, so you can use the open source like Red Hat business model. You use the product, but then when you want support, you want someone to call and be like, this is 24/7 call center. Hello, there's an issue here. Can you come and help us deploy it and yada yada yada, or come help us configure it? It's the license.
So do we have all the features on the open source?
All of the features. There might be like some custom integrations or something, but integrations, for instance, good point about integrations. We have another GitHub that allows you to do all of your integrations, data mapper model. Takes any data, normalizes it into any schema. So usually, like you might have some like custom, integrations that are pushed here before here, but integrations are easy to get from this engine, which is open source anyways. Sapienta data mapper model. But essentially, this is where you would get all of the pushes on the attack flow detector. Ooh. Just in time. Any other questions? Laptop might die. I'm with you. The laptop might leave us. I'm still with you.
What do you do with all the logs that you process?
You can delete them, or you can keep them.
My actual question is the operational question of how long you.
Oh, this is completely on-prem. I never get your data. This is not SaaS. You never send me the data. It's crazy that you would send me the data in terabytes and terabytes. Why? Don't send it. The telco company is gonna make so much money if you do that. Don't send it. Here is my algorithm. Just deploy it locally. It would be crazy if I take your logs. There's a lot of PIIs. Don't do that. Don't send your data. Come on. I think AI is the biggest data transfer scam in the world. I think we're all sending our data so that the telco companies make a lot more money and, energy companies make a lot more money. But don't send your data, especially big data. Don't send it. Keep it. It has a lot of secrets. You might figure it out later, but it has a lot of secrets. Any other questions? Yes.
So it's there a pre-trained model that ships?
None of these are trained. These are all semi-supervised. Training means that it is training on your data. But do we know any model that trains on your data that is good? Anomaly detection has been around in cybersecurity. Do you guys like anomaly detection? Or do you think it makes a lot of false positives? It makes a lot of false positives. Why? Because if you train on my data, you're assuming that my data is going to be the same. You're assuming that the attack that I got yesterday is going to be the same attack I get tomorrow. You're assuming that the normal behavior of the user yesterday is the normal behavior tomorrow. Never train on my data. Never train on any data. You train on knowledge. You asked me about clustering. Clustering is completely unsupervised or supervised on data. You think I would train it on my data? It wouldn't work for anybody other than me on my data during that time. It wouldn't work for my data tomorrow. It would work for my data. I lost my screen. But essentially, it would work only during that. But if you use semi-supervised or knowledge-based, you're training, quote, training. Data science people will not like this video, but you can call it training the model on knowledge, on concepts. You're not training the model on data. You're training the model on what it means for Bill when he said, kill chain is sequence. You're training the model on what it means to have tactics that are sequence. You're training the model on what it means to put the data and look at all of the fields. And what is the meaning behind the fields? What is the meaning behind the field port? Is port 80 and 81 closer or 80 and 443? 80 and 443. That's knowledge. But if the model doesn't have knowledge, it thinks, oh, 80 and 81 are closer than 75. No, 80 and 81 are not very close. This is HTTP. 81 is a system port, never used. If it's used, don't group it with my HTTP traffic, please. This is, you group this with something that's very, very critical. What the hell is using 81 or 79 or 78? I don't know anything that uses those. But 80 and 443, group them together. So that's the knowledge that you give to these models. You give these models knowledge about the subject matter expertise. And that's why this field is called expert AI or expert machine learning. You're giving it expertise. Not like anomaly detection, you bring it and you're like, train on this data, baseline it. We do a demo for the first 6 months, we baseline it on all of the normal activity. You think I'll have normal activity for 6 months? Normal activity is not something that I can even assume is gonna be the same for tomorrow. So, fantastic question, Zain. None of this is supervised. None of it is supervised. The only part that was semi-supervised particularly was the language model to know what string gives you what technique. And that was essentially a humongous project over 3 years that we had a human being sit and build a specific data set of consistent taggings from sentences or alerts to techniques, because the techniques that you have today in rule sets, they're for marketing. They're not actually things that you can use for true tactic correlation or true grouping. So we had to make them completely from scratch. So we downloaded all of the rule sets from all of the endpoint detection and network detection, all of the rule sets. We had someone that you can watch their videos on YouTube come in, and they stayed in the company for 3 years, and they literally tagged things by hand. And it took them 3 years, not because it's a lot of data, because they were not consistent. So they would delete their data, they would make regular expressions to keep themselves consistent, they would try again, and then they would not be consistent. Data is pretty big, and so on and so forth. So it was a real effort of getting some sort of a labeled data set to just ground the model a little bit in language models. And that's the problem with natural language processing. Unlike clustering or sequencing, they are prone to hallucination. They're prone to being essentially sounding confident, but not being right. So what we did was, over 3 years, we make the data set to ground them. And the human that did that essentially had to make sure the data is consistent, yada, yada, yada. But long story short, none of this is actually fully trained in the supervised machine learning method that you would be used to in other machine learning projects. This is completely under the realm of semi-supervision or weak supervision, based on expertise rather than data. Thank you for the question. Any other questions? If not, I appreciate you very much. Absolute delight. Very grateful. Thank you.